And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop, where today we're carrying on with our Bush TV22 adventure. If you haven't seen the first episode, go back and have a look at that first, otherwise this might not all make sense. Meanwhile, let's get that capacitor out and on the reformer. Right, the mains smoothing can itself is actually accessed from the front here, and it's this in a clamp. Now, looking at the back of it, one, it's pushed too far in, and two, I think it's been got at before. I might have done it 8 years ago. Just had it on the reformer for a while to see if it was all right. And quite often they will come up. So, but that was 8 years ago. Let's take it out and put it on the reformer again and see where we get to. Right, I'm on the clamp. Let's just open that right up. And then if I push it from behind, it should come out. Gently, gently does it. Okay, I'm going to grab that there. There it goes. Yeah, it's definitely had some soldering work done. It's got a bit tight in there. I'm going to have to undo the clamp a little bit more, I think. Yes. Have we got enough wiring? I can't see that I'm pulling anything tight, but then again I can't really see. Right, bear with me. Let's get a blooming light in there again and see where we're at. Yeah, there's a black lead that is very, very tight. Okay, let me turn around and get in there so we can unsolder that little fella. Mind that tube, right. It's right down in there, so that's going to be fun and games to get at. But I can see which lead it is, it's that one there, so if I can just get an iron on it and pull, I think it should just come straight out. This of course may have been replaced in its life. Looks to have been soldered before. Yeah, it says October, oh no, it says October 52 on it as well, it's original. Okay, I've removed that lead. The red one's pulled tight. So what is red connected to? Oh, well, red's connected to red. That would make wonderful sense, wouldn't it? Got it. Okay. Is the remaining green lead going to be long enough or not? I think it is. Excellent. Spin around a little bit. There we go. You can now see what's going on. If I just desolder that green lead, which is going to the non-coloured terminal.
there it is. So we've got 60 and 250 microfarads. Red is the 60 275 volts. Red outer 60 275 volts. Maximum working 350 volt surge. One thing we notice is there's no bulge or anything at the top of that. So I think we give it the benefit of the doubt and put it on the reformer. October 52, made in England. How wonderful. Right, okay. I'm just going to give that a bit of a clean down before we get the reformer out. And yeah, we'll just have a little look. Might well be all right. I think the oldest capacitor I've ever had, which measured good, or reformed okay, was one from 1949. Who knows? Right, okay, pop back in a minute. We'll get the old capacitor reformer out. Okay, I have set up the Mark 79B Dreadnought capacitor reformer. Or is it 83B? I can never remember. Anyway, it's a homemade bit of kit. I've set it for a maximum output of 231 volts at the moment. This capacitor said 275, so we're in there. And right, we need some crocodile leads. I'll just switch off the supply for a second and switch this to there and then push discharge. That should drop away to nothing. There we go. Okay, and this meter will tell us how much current is being drawn by the capacitor. So let me just get a couple of croc type leads. So that one goes on the black. This one goes on the red. I shall pop that on that one to start with. We wind this knob round here. I'm going to start at 320k. We're going to switch on and we'll see this start to draw current as the capacitor charges. There we go. So that is drawing current. By the way, you'll notice it was drawing current when the meter was connected. It's because the meter's got an impedance. Right, now we sit and wait.
1 hour later.
Okay, so we're about an hour into our reforming process. And as you can see from the meter here, we're down to 282 microamps. So I'm just going to snick into the 100k position now. And as you can see, it's instantly up to 500 microamps, but rapidly falling away. The more the capacitor reforms, we can lower that resistance, the faster that will charge. So yeah, let's wait again now. Another hour has passed. We are on the 100k setting and we are down to about 170 microamps. So I'm now going to lower the resistance again to 32k. And as you can see, it's charging very quickly now indeed. And the current is falling off. So I'm just going to leave it sort of quarter of an hour, then go down to 10k, and then go and have a curry. I'll be back in quarter of an hour. Right, I've come back from having a curry, and I can tell you, it's freezing out there, and it's not so warm in here either, but we are on at 32k, and we're sort of at 150 microamps, so I'm going to go to 10k, and already, look, it's dropping right down there. So this is all good news. So yeah, let's leave that a while and see where we get to.
The next day.
It is the following evening. The keen-eyed amongst you will notice I've switched connections on here. So the good news is while I was waiting for all this to happen, I fixed me network storage, so I've now got a schematic, so that's good news. And that first section turns out to be the 60 microfarad side of things. And at the close of play this morning, our 60 mic section was consuming 150 microamps, which I reckon's bloomin' good. Now I've put the 275? No, 60, 250 microfarad section on. It was about an hour and a half ago, and it was pulling 700 microamps. This is with the 330k series resistor switched in, and we're now down to 270 microamps. I'm now going to lower that to 100k, back up to 700. The can is very cold to the touch because it's freezing in here. So yeah, on it goes. I'm not going to do any more of these short little cuts because it ain't very interesting, is it? One thing I did find was a calculation for sort of acceptable leakage, and this is sort of dated in the 60s, where you take the capacitance in microfarads, multiply it by the working voltage, so that would give us 60 by 275, which is 16,000, divided by 10 gives you 1.6 milliamps plus 100, which is 1.7 milliamps, 1700 microamps, which seems quite a lot. Well, that first section well exceeds that. This second section is already within limits. But yeah, I'm just going to leave this to cook. Come back when it's all finished. See you in a bit. Bye.
3 days later.
Okay, so it has been a number of days. And as you can see, we've fallen to around about a milliamp. So that's 1,000 microamps. It was 1,100 a minute ago, whether the mains has varied slightly and skewed my results, but any which way. And I'm thinking, that's quite a lot of leakage current. Is it going to be any good? Well, we've done a bit of research and a small calculation, which I've got here. So there was the result. Let me get the glare off the screen. There was the result for the first cap, 150 microamps, very little. Second one, obviously a bigger capacitance. When I did the calculation a few minutes ago, there was 1.1 milliamps, 1100 microamps flowing. And then I thought, well, I wonder how much power that's actually dissipating and trying to warm our component up. And power is volts times amps, 275 times 0.0011, which is our 1.1 milliamps, is equal to 0.3 of a watt, which isn't a lot really for such a big can. Now I was hoping to find another capacitor, a more modern thing, and see how that performed, to see whether we can make an informed decision here. But I don't, is the answer. So that went out the window. I'm just going to switch the power supply off. I'm going to click this round a couple and then hit discharge. I'm just going to discharge that capacitor. So that's flashing is indicating we're still discharging. Go a bit more. There we go. Go a bit more again. So that should collapse the voltage across our capacitor. By the way, I reformed in the end at 270 volts because I was concerned about variations in the mains upsetting my power supply because it's not regulated. So that's where we're at. So maybe these figures could have been a shade higher, but they've all gone very much in the right direction down. So yeah, right, things to just be aware of is the voltage across here, because obviously a few moments ago there was 270 odd volts across here. 0.9, that's not going to do us any harm. The other thing is this will probably charge up slightly as we've removed the resistor. So 2.5 volts. What's on the other one? 3.7. You see? Oh no, hang on. It's those two pins. 0.7 of a volt. Right. That's not going to do any damage. Let's just switch a light on so we can see what's going on a bit more. And let us check to see what the actual ESR is of this 72-year-old capacitor. Oh. Okay, I'm in the way of everything here, aren't I? Let's put that there. Let's zoom in a bit so you can see. Right, okay. So between black and red, that's our 60 microfarad section. 61.6 microfarads, an ESR of an ohm. I'm actually very happy with that. So, okay, let's go across the other section. 240 microfarads. Look at the ESR, 0.36 ohms. 72 years old, and I'm betting this capacitor's absolutely fine. Let's get it refitted. Not sure how much you're going to be able to see here, but I've got the capacitor sort of in the front a bit, and I can just see the sort of first lead in about the right position. So I'm just going to attempt to get in there and solder this up. Oh, this is going to be super awkward. Oh, that's got it. Okay, so where's the black lead? Bingo, that's all three soldered back on. I'm going to push that back into position. I don't think it should have been as far in as it was, so I'm just going to sort of leave it there for now. And we'll tighten that washer up. Right, I suppose the next job is to have a look at our pickled line output transformer. Okay, I have donned some teal gloves for this job because it's going to be fairly horrible. Now this is our jar of stuff here, and you can't see through it anymore. There is in fact a line output transformer in there. So yeah, let me open this and extract our transformer and see what has happened. Well, it's not quite there yet, is it? You can see we've still got some pitch. Where's the camera? We've still got some pitch remaining on our EHT overwind. We've got a broken wire there. I'll tell you what, that's from the heater for the EHT rectifier, which is disappointing, but we shall have another, so let's not worry about that. Yeah, most unpleasant. It's all sort of flaking off though. Now, I wonder if I sort of flake off what I can and then leave it to soak a bit longer, or I don't know. It's very, very soft and sticky now. It's nasty. It is all just coming away, but I really don't want to upset it as much as, you know, I don't want to disturb it, sorry, any more than I absolutely have to. It is all just coming away though. I'm using very, very light finger pressure here just to sort of pull off what I can. But if I just get that little pick, I don't want to pick anything up at the moment. Oh! It is all just falling away. I think what I'm going to do is I'm just going to wipe off what I can here and then get some fresh white spirit, empty the jar out and go again. Gosh. I'm going to have to remove that EHT rectifier now anyway because I think it's broken. So this has been kicking around in the workshop, sort of out of the chassis for, well, 8 years. So it was last utilised in Colin's set to prove a point. Just sort of put that in and have a little rinse about. Oh, it's so nearly there, isn't it? So nearly there. Right, so I'm just going to go and environmentally dispose of this unpleasantness, and we'll refill the jar and just give it another few days, I think. This is why I quite like doing TVs like this, because you can't rush these things. You know, we've taken days to reform our capacitor. This is taking days to do, and it's just quite a nice, cathartic, relaxing progress. And if I was starting this from scratch, I think what I'd do first is try and reform that capacitor whilst doing leaving the line transformer to soak, and then probably recap the chassis. But of course, it didn't happen like that because of because we needed to get this going very quickly to prove a point in another set previously. So right, I'm going to go and get rid of this. Yuck. I have cleaned and dried my jar. I'm going to pick my line output transformer back up and put it back in the jar and refill up to the sort of level I need to be at with a fresh bit of white spirit. There we go, that's fully submerged it. And once again, I'm going to leave that for a few days whilst that softens and dissolves the remaining of our pitch. Lovely. Pickled transformer. Right, let's wait. Right, the next issue I've got to deal with is this very loose and wobbly base on the end of our tube. So I think what I need to do is remove the connector, pull that off somehow, remove the ion trap magnet, because this tube, it's a bent gun tube. The gun is angled and they use a magnet to scoop the electrons back towards the screen and let the ions sort of crash into the bowl. It hasn't got an aluminized screen, so it would suffer badly with ion burn if they hadn't have done that. So what I really should do is remove the CRT completely from the chassis, but it's been there for 72 years. It probably might not be an original one. I can't see the Mullard label on it, so it may well be a regun. And it has got stunning emissions, so I don't want to mess with it too much. But I think what I'm going to do is pull the base, pull the connector off the tube connector, take the ion trap magnet off, clean round. You can see the line in the tube where the ion trap magnet lines up. So yeah, and the other thing, this focus mechanism, despite the fact unbelievably it hasn't seized up, is horribly filthy. So let's try and clean a few bits and pieces up. So first thing to do is to try and ease this tube base off the connector itself without letting the air in. Terrifying, to be quite honest with you. It seems to be stuck on the bottom more than the top. Oh, that really is very very stiff. And of course I've got nothing to pry against because I can't. I wonder if I can just get in there with a screwdriver and just ease that. Oh, that's working well. Ease that against the base itself. Just yet, it's coming. Got to be so careful. Yes, right, we have success. That is good. So the ion trap magnet is already very loose, so it will need adjustment anyway. So I'm just going to slacken it all the way off. And it's stuck. Right. Is it going to unstick or is it going to be stubborn? It is stuck. So I'm just going to get a little bit of WD-40 in there and just clean that off. Let's let that soak in for a few minutes, and hopefully that'll just free the ion trap off and I can remove it.
Okay, it's left that a few minutes to work, and yeah, it's worked beautifully. So I can now extract my ion trap magnet. That's what it looks like. Put that to one side for a moment. We need to clean this crud off this neck. So I'll just get a bit of IPA, I think. I want to clean all this oil off anyway that's got in there. That will have flowed down into the connector, so let's get a bit liberal with it. Try and make a bit of a job there. You can see that on that camera actually. You may be able to do so. Let me zoom in for a moment. Yeah, you can actually see the CRT gun look is at, where's my finger? It's sort of at that angle in there, pointing up. So our electrons are shooting up, and then the magnet bends the electrons back down again to hit the phosphor. But the ions that are heavier hit the bowl of the tube, the sort of funnel shaped part around here, and don't hit the screen, so you don't get any ion burn, which is where the ion crashes into the phosphor and causes it to sort of fail. Right, well, this is cleaning up quite nicely. You can see there's some residue on the neck there that was left behind from that sort of gauze on that ion trap magnet. So we need to attach this, bond it back to the glass. Now, back in the day, that was done with an adhesive called water glass, which is very much no longer available. So we need to use something else. Now, don't, whatever you do, be tempted to use super glue, because obviously as the glass warms up, the super glue doesn't expand and it will fracture the glass envelope, so don't do that. What I'm actually going to use is an old favourite nail varnish, and I'm actually going to thin it down so I can run it sort of down behind this loose base and hold the base into position, probably with some tape, and then it'll cure and just adhere the base to what remains of the water glass that's in there. So yeah, right, you might tell I'm a little bit nervous about doing this. I did just have to cut there and stop because there was still some IPA that hadn't evaporated. That's all gone now. What I'm going to do, a little bit of electrical tape. I'm just going to use that to hold the base onto the tube at the bottom here. Get as tight as I can. Okay, that'll do. Still a load of movement in it, as you'd expect. I've got this plastic lid here. Now, this I know is acetone resistant. What I plan to do is put some nail varnish in the bottom of there. Nail varnish. I'm then going to dilute it by about 1 part nail varnish to about 2 parts acetone. Suck it up into this syringe and then squeeze it down the gap in the base there. And then I'm going to put another piece of tape across the top just to hold it, and we'll see how we get on. I've got to work quickly because I don't know if this is acetone resistant. So first thing to do is just sort of decant a bit of our Rimmel 60 seconds nail varnish into there. That should do us. And then open my bottle of acetone. I don't want much, so there we go. In fact, most of that can go back in, I should think. That was actually perfect. Amazing. Right, we shall mix it about by sucking it up and pushing it out of the syringe, I think is probably the easiest way to do it.
And then I'm just going to flood this down in there. Now apparently the acetone will soften the original water glass. So that should help. I think I've made far too much here. I'm going to squish that back into there. And I'll get another piece of tape and just tape that base back onto the neck, just to hold it all tight. I might be tempted to take this tape off and retape it. I think I might. It's certainly flowing through, so that's not a bad thing, I don't suppose. Yeah, it's actually flowing through so much. I've put so much in there, I think that's not going to help us. Right, well, let's get a bit on the side maybe. Tempted just to flow a little bit more in there. What's the worst that can happen? Oops. It is dripping all over my bench, but that's okay. Just wipe that up. Right, now I'm going to leave that for 25-30 minutes, I should think, and see if it's improved the situation. Right, it's the following day again, and I'm absolutely delighted with the bond that the socket on the end of the tube there has formed. That's gone really well. I'm just going to clean off, because where I taped it up, some of the nail varnish acetone mix just sort of tracked along a bit, so I'm just going to give that a little bit of a wipe off. Not too much on there, because I don't want to soften the glue again and cause it to come off. Just blow on it just to keep it clear. There we go. So pleased with that. Let's just put the acetone back out the way. Clean it off the bench, because yeah, so you can clean some of the blue colouring out of the bench. It's strong stuff, is acetone, and it's left the bench a bit sticky. Hopefully that'll sort itself out. Right, replace the ion trap magnet. So it was that way around on there, and it sort of lined up roughly with that line that's been painted in the tube there. This will require adjustment later on. I'm not going to do it up tight, I'm just going to nip it just so it doesn't flop about. There we go. Right, I'm not going to stick the tube connector back on yet, because yeah, I want to deal with the top of this chassis. Now obviously I've cleaned it a bit when I went round it the first time, but I think it needs a bit more of a birth date. So I'm just going to remove the valves. So that's one. This is actually the line output valve itself. That's the boost stroke HT rectifier. Line output valve is a PL38. This is, I believe, the line oscillator, ECL80. And then we've got another ECL80. And I believe this is sound output here, hence the sort of bit of shielding on it. There we go. That's a PL33. Right, so we've got a lot of detritus to shift off here. I'm thinking a quick go round with a microfiber cloth just to start with. Well, that's looking a lot better. Very satisfying too. One thing I haven't done is round the anode button there. It seems to have some sort of lacquer on there. And I don't remember last time it running, it giving me any sort of arcing problems. One problem I might have is, I don't know where the EHT connector is. So that could be a bit of a bother. But I know on these sets also they are insulated. There's no like cap or anything to go around it. So, oh, I've got paper stuck in it now. What is this stuff? I wonder if it's some sort of anti-corona lacquer that was put on the tube back in the day. Could well be. I think we're going to leave that. If it needs painting with a bit of lacquer, we shall paint it with a bit of lacquer. But other sets I've done, I don't believe that's the case. I'm sort of thinking this is a regun tube, though I've got no way of knowing. But that now is working beautifully. There's still a bit of gunge in there, but I think we're all right. I could, you know, take the tube out, take this support out. This assembly here, the focusing assembly, isn't actually attached to the tube. The tube slides in. The coils, however, are stuck to the tube, and sometimes a bit of heat and a bit of WD-40 down them will bring them out, but you've got to be so gentle, one, not to break the glass, and two, not to damage the coils. So I'm voting to leave it all put. So, yeah. Right, I think it might be time to have a look at our pickled Lopti. I've donned my gloves again because it's time to get the line transformer back out. I'll just show you the colour of the juice before we go anywhere. It's sort of black tea sort of colour, really. So let's get in there and fetch it out. Yeah, that's still a few bits coming off there, but no, we're good to go, I think. Whoa, what was that? Oh, it was my glove stuck on one of the tags. That's all right. I thought we'd had a catastrophic issue. Where's that little brush? Oh yeah, it's got rid of most of this. I was worried about up under the EHT winding here. Just a little bit there to come off. Where's my toothbrush? Be very careful of that wire. Do you know what? I think we'll leave it there. So my valve EHT rectifier looks to be shot because we've got a wire broken off it. That's not such a big issue because I got a replacement coming. Had a lovely conversation with a guy on eBay yesterday. So that's all good. So yeah, I think all we need to do is sort of wait for that to dry out and then give it a coat of anti-corona lacquer. Excellent. Okay, our line transformer has sort of the white spirit has all sort of evaporated off. Now, one of our legs has come broken off at the envelope of our little EY, was it 51 I think, EHT rectifier. So I need to take it off anyway. So let's just put the iron on and desolder that. A bit of fresh solder on that. Okay, so just gently remove that lead there. That one should just fall off, which it has. And then gently remove this one from the EHT winding. Good. That's got rid of that. I'm just going to see if this will come off here. In fact, I'm going to leave that. Let's not rock that boat any more than I have to. Right, let me just mop that up. Okay, so I sort of want to stand this here now and spray it with my lacquer, which I have just had in my hand and I've now mislaid. One moment, please. Right, this is RS anti-corona lacquer. So there we are, giving it a good shaking, and we are going to liberally apply a coat to our transformer. So the two bits that really are important are the EHT overwind itself and the heater winding for our EHT rectifier. And the simple reason is the EHT rectifier floats, so its heaters are actually up at EHT. Now, if you've seen other TV22s on the web, you'll notice that this transformer is a little bit odd. Normally they've got like a sort of T-bar coming out the side, and this one is indeed a little bit odd. I remember Ed Dinning commenting, you know, Bush used a number of different manufacturers back in the day, but he'd not seen one quite like this before. So there. Let's just gently turn that, if I can, without it falling over. It's fallen over. Let's just spin that round. Yeah. Well, it's got my fingerprints on it now. It's definitely mine. Right. Let's leave that for a good few minutes just to dry, and then we'll give it another maybe 2, maybe 3 coats. Right. Right, well, it's actually been sort of week 10 days since I've been in the workshop, and this lacquer has cured very nicely, or dried very nicely. I'm very pleased with that, and I think the next thing to do is replace our Duff EHT rectifier. I've bought a new one
from eBay because I didn't have one in stock. I have to say I'll link the eBay seller in the description below because his packaging was absolutely stunning. This arrived inside a tin can, like a baked bean can. Very clean, not a problem, but just, you know, that's a fragile thing. And there it was, all packed in this can. Kudos to the seller, that was brilliant. So I've got my new AHT rectifier, we need to fit that. And the other thing I need to do, because these terminals clearly got a dose of varnish as I was painting the transformer. So I'm just going to heat those up, clean up the solder. And clearly the same with the EHT rectifier connections. So the EHT AC side of it comes out here, and then that connects to the PIP on our EHT diode, and then the other two legs go over to here, which is this heater winding, and also provide the DC rectified out. So this heater winding is floating up at our EHT level. It's probably somewhere 7 or 8 kV on this set if it's going to work properly. So yeah, first things first, let's put the iron on and remake these connections. I've got the Fumex filter there, fume extraction, because we're going to be chucking out some unpleasantries there. So sounds like that needs a service, but anyway, we shall carry on. Alright, I am very happy with that. So here's our new EHT rectifier in its original Mullard guarantee paper. There we go, the Mullard guarantee. The valve in this carton has been thoroughly tested before dispatch and is guaranteed for a period of 3 months from date of supply to the user. I think we're somewhat outside of that 3-month period. And there we have our brand new EY51 EHT rectifier. So I'm just going to gently bend the heater leads out. And those are going to attach on there. And that's going to attach on there. Gently straighten out that end there. And I do need to put some sleeving on that heater winding end. So you can sort of see there was a piece on there originally. I'm going to use a bit of more modern heat shrink, I think, and then that will sit in there very nicely. So I think I want to work quite quickly with the iron on here because I don't want to stress out the glass envelope too much. So let's go very quickly there. See, that took solder beautifully as well. Right, I'm going to need a little bit of sleeving. So we'll go with some of that there. That should be ideal. In fact, I think I'm going to solder on that end first. Should we have the label facing outwards? It doesn't really matter, but that'd be nice, wouldn't it? I'm going to solder that end on there first. And I do want to be a little bit careful with the shape because I don't want to stress any of this 72-year-old windings out, although it will have a little more support now because of the lacquer we've put on there, of course. Right, try and hold this in place. Just gonna bend that round and snip it off, I think.
And the trick is when making any sort of high voltage connections is to get the, don't leave a sharp edge on the solder joint, which can sort of promote corona discharge. So we want that joint as round as possible, really. Excellent. So that is our EHT rectifier replaced on our transformer. Happy days. Common failure for this type of rectifier, by the way, if you ever see one glowing blue, then it's had it, or you get a picture ballooning with the change in brightness. That's also a common sign that the rectifier is no longer able to deliver the current required. Right, let's just get rid of this solder. Then we have another issue. Thankfully, one I think I can mitigate. So when I took that transformer out 8 years ago, obviously in my book of notes at the time, I wrote down the connections, but I didn't say. So there's the base, obviously. So we've got 6 connections there, and we've got 2 posts that sort of support it. You can't see that. Let me zoom out. In this sort of mounting adapter thing here, because all these transformers have made various different ones, and this is a little bit different from the usual. But that slots in, and obviously I can slot it in that way or 180 degrees out, and that I didn't write down. Thankfully, I think I've got a picture on the website. So yeah, that's the next job, is to put the transformer back in the right way around. Let's get on with that.
It's Future Doz here doing the editing, and once again this episode has gone on long enough already, so tune in next week and we'll see if we can get first light out of our Bush TV22. Thank you very much for watching. Click like, subscribe, do all that rubbish, and I'll see you very soon here on Doz's Television Workshop. Cheers.